Calculating and interpreting the correlation coefficient. In practice, we will use a calculator to calculate the correlation coefficient. Here we show the required keystrokes for the Casio FX-A3ES, one of the most popular makes of calculator. For the Casio FX-A3ES, we start by pressing Mode, 2 and 2. This will display two columns called X and Y and waits for you to enter your data. After entering each number, press equals. It is easier to enter the X values first and then use the arrow keys to go back to the top and enter the Y values. When all values have been entered and checked, you can press On, which will clear the display. To retrieve the value of OR, the correlation coefficient, press Shift 173 and equals. The value of OR for the entered data will be displayed. A number of junior certificate students sat exams in maths and science. Each exam was marked out of 20. The scores of these students are listed in the table below. So here's the list of students. This was their maths mark and this was their science mark. So their maths mark will be X and their science mark will be Y. Part 1. Calculate OR, the correlation coefficient for this data, correct to 2 decimal places. So entering the data in a calculator and following the steps from the previous slide, we get OR equals 0.4908 or OR equals 0.49, correct to 2 decimal places. Part 2. Does the value of OR indicate a positive or negative correlation between the maths and science scores of these students? Give a reason. As OR is greater than 0, so it's positive, there is positive correlation between the maths and science scores for these students. Part 3. Would you say that the correlation is strong, moderate or weak? Give a reason. As OR lies between 0.3 and 0.7, we would say that the correlation between the scores is moderate. So between 0.7 and 1, we would say it was strong, and between 0 and 0.3, we would say it was weak. Correlation does not mean causality. It is important to realize that just because there is a high correlation, either positive or negative, between two variables, it does not mean that a change in one variable causes a change in the other. For example, there is probably a strong correlation between the number of ice creams and beach balls sold in a seaside shop, but neither causes the other. They are both influenced by the weather and the temperature. This is called a lurking variable. Sometimes there may be a strong cause and effect, but in one direction only. For example, there is a strong correlation between smoking and lung cancer, but anyone who suggests that lung cancer causes smoking would be laughed at. The key phrase to remember is that correlation does not imply causality. There is very often a number of underlying factors that affect both variables. Thus, you should be very wary of media sources suggesting that just because there is a high correlation between two quantities, that one causes the other. On the other hand, if we are trying to show causality, we need to first show correlation. If there is no correlation, then there cannot be any causality. So correlation is not irrelevant when it comes to deciding if one variable has a causal effect on the other. Just be careful not to go too far with the conclusions.